Hello friends, my name is Rahul Purohit and I'm from BTech first year, DICT Gandhinagar. And today I am going to present you forward a model on traffic flow. So let's begin.
I've chosen this problem because traffic jam is becoming a major problem in many cities, and many cities are facing pollution due to it. And the recent example is Delhi and Ahmedabad too is facing the problem of traffic jam. So I have chosen this problem. So I have made certain assumptions before starting the problem. I have considered a one-lane road, and I have considered the length of the car to be constant of every car, that is capital L. The distance between every two cars is small d, and I have considered that there are no diversions, there are no underpasses or no bridges or no accidents on this track, and this track is continuous. The problem. So I have considered a one-lane road, and the traffic flows from left to right, and the length of the car is capital L, and the distance between them is small d. So I have considered certain variables, so I have mentioned it here. The position of car will be mentioned by x, the time period will be t, number of, that is the car's flux, is denoted by j of x comma t, density of cars is dx comma t. I have defined these two ahead, so we will see further in the video. Velocity of the car is v of x comma t, so these three are functions of x and distance and time. So let's define density. Density is the ratio of number of cars in specified space interval, that is position interval, to the length of the specified interval. Suppose in the PDF I have mentioned that we have taken an interval from x0 minus delta x to x0 plus delta x. So the length of the interval would be 2 delta x, and we will take any position from that interval. So after defining that, I have found a formula from it, and the formula turns out to be d equal to 1 upon L plus d. Flux. Similarly, I have derived for flux in the PDF, you can see it. It is the ratio of number of cars passing through position x0 during particular time interval to the length of the interval. So the formula turns out to be j equal to v upon L plus d. So here both are the function of x and t. And I have, in the description, you can see the site where there is a PDF, and you can view how we have derived this. So seeing both the formulas, we can see clearly that there is a relation between density and flux, that is j equal to dv in the model. So we had considered, now we will consider a constant volume, that is a volume of a road. There will be many cars in that road, so we have considered a constant volume and an interval cx during the time interval ct. According to the control volume, that is cv, we have short formed it to cv, control volume, that is constant volume, the net change of number of cars in interval cx. We have supposed that the first side and the second side of the queue, the first side is from where the car will enter, and then the end side is from where the car will exited. So that is cx during ct, the time interval that one car takes from entering the control volume and leaving the control volume, is equivalent to the cars during this time interval through boundary. So the number of cars passing during this time or exiting this area. So now taking this statement into a mathematical form, I have wrote this formula, and now in the form of density and flux, I have written this formula: 2 delta x d of x0 t0 plus delta t. The car may have lived before some delta t time, and I have chosen some t0 minus delta t time from which I have started to take the time. So I have mentioned this, and this is j of x0 minus delta x, from the frame where the cars start coming in, that is the entry side of the control volume, and this is the exit side of control volume. So I have taken the flux and here the density. Now we want to find the particular value, so we have to take the limit, and if the limit exists, then we can say that it is analytic, and if it is analytic, then Taylor series can be defined of density and flux around the point x0 and t0, and as you see, it is a two variable function, so there will be a Taylor series expansion in two dimensions, and after certain mathematical calculation, the formula turns out to be this: del d upon del t equal to minus del j upon del t. Now we have found a formula for flux and density, that is j equal to dv. So in mathematical form, we can write this dt plus dvx equal to 0. Note, we cannot take out v from partial differentiation because v is a function of x and t. If it would be it would have constant, then we would have taken it out. Now we will take two cases for this formula, that is dt plus dv of x, that is partial differentiation of density plus multiplication of density and velocity and their partial differentiation with respect to x, that is position. Now we can formulate the problem and go further and solve this PDE, but it will require a rigorous math, so I have taken two cases. So let's begin with the two cases. First, I suppose that the velocity is constant, that is some value of velocity is a. Then the velocity, if the velocity is constant, we can take out v from this partial differential equation as it is no longer a function of x and t. So I have written this formula, that is dt plus a dx. And now I have taken the second case, that is varying velocity, and I have supposed that the velocity is a function of density, as that is, if density changes, velocity will change according to it. And I have supposed that it is a linear function of density, so v of d equal to a minus bd. So when we keep this formula here and do certain manipulations, the formula turns out to be v equal to v max 1 minus 2d upon d max. This is the formula of velocity, and this is known as a very famous formula. This is Greenshield's model. And so now I conclude my model, and I want to say that the merits of this problem is that we can control the velocity of the car, so it should run so that it can avoid the traffic jam. And so if we avoid traffic jam, then we can save the environment by stopping pollution. There are two types of pollution which mainly cause in traffic jam, that is air pollution and the noise pollution. And we can also save the wealthy fuel, that is the non-renewable energy source like petrol, diesel, and all the types of fuels. It can be saved, and so I have declared this model.